Now that you know the build has 4 stages, error messages stop being a wall of noise. Because errors come from different stages, and knowing which stage produced one tells you where to look. The preprocessor complains about files it cannot find. The compiler complains twice, in 2 quite different ways: syntax errors, where what you wrote is not C at all, and semantic errors, where it is perfectly good C but it does not mean anything sensible. The linker complains about things that are missing entirely, and its messages look nothing like the compiler's. And runtime errors produce no message at compile time whatsoever. The program builds perfectly and then falls over. In this lesson we will look at the first 3, which all come out of the compiler stages. The next one is entirely about the linker, because it deserves it. Here is the first one, and it is the friendliest error in C. Fatal error, stdio.h, no such file or directory. Note the shape of that message, because every GCC diagnostic has it: file name, line number, column number, 110, line 1, column 10, then the severity, then the message. And then GCC prints the offending line back at you with a row of carets underneath pointing at exactly the text it objected to. 2 things cause this. Either you have mistyped the file name, which is what happened here, or the header genuinely exists but the compiler does not know where to look. In which case you tell it with -I and a directory. And note the last line, compilation terminated. This one is fatal, so it stopped immediately rather than carrying on and producing another 100 errors that are all really this one. Now a syntax error from the parsing stage, and this is the single most useful thing in the chapter. The message says expected semicolon before return. Look at what GCC is showing you. It names line 5, column 30, and it prints line 6 as well, with the word return underlined. Why? Because the compiler did not discover the problem when it read line 5. Line 5 looked perfectly fine on its own. It only realized something was wrong when it read the next token, found the word return where a semicolon should have been, and worked backwards. So here is the rule, and write it down: a missing semicolon is almost always on the line before the one the compiler names. The same goes for a missing closing brace or a missing parenthesis. When a syntax error makes no sense on the line you are pointed at, look up one line. And notice how helpful modern GCC is being. It has put a little semicolon in the caret line, showing you exactly the character it wanted and exactly where. And the third kind, a semantic error. Int x equals, allo. Read that line as a parser would and there is nothing wrong with it at all. It is a declaration, an equals sign, and an initializer, all perfectly well formed. The problem is the meaning. An int is a number and a string literal is an address of some characters, and the compiler will not quietly pretend those are the same thing. Initialization of int from char pointer makes integer from pointer without a cast. The way to recognize a semantic error is that the message talks about types rather than punctuation. Syntax errors say expected semicolon or expected closing brace. Semantic errors say from char style or incompatible types, or too few arguments. And when you see that phrase, makes integer from pointer without a cast, remember it comes back to visit you in chapter 12. When pointers arrive properly, and it usually means you have forgotten an ampersand or an asterisk somewhere.